Hello, this is the demonstration for Group 6. I'm going to start this off by turning on the car. This device is actually powered by the cigarette port. It outputs 12 volts, and this adapter actually outputs 10 watts. And so that wire that's coming out leads to the camera. I have one QR code set up over there. And I'll put the camera right here to show the boot sequence of this Pi of the device. I haven't touched anything, but it will automatically set up. Once it sets up and runs the GUI, it will beep in like 5 seconds, but that's in order to tell the user to log in. You can log in by putting your credentials there and just tapping there, or you can actually log in through the RFID and you can just click this button and log in like that. Once you're logged in, you can start scanning QR codes after you click the switch to the side. Once you do that, you can now scan QR codes. Close the, we can clock out by flipping the switch to the other side. Once we've done that, we can actually go back to the main screen and click this X button. Once we've done that, we can go over here into the CSV file, because that is a backup. There we go. Okay. Click that. There we go. Oh yeah, look at that. So we scanned it at 1404, yep, a minute ago, and bin 144. We can check out that bin number. There we go, yep, bin 144.
For the following demonstrations, I started by reading QR codes under good and poor lighting conditions, as well as taking pictures of their surroundings. Both QR code demonstrations were read at about 4 to 5 feet from the Raspberry Pi camera. For the first demonstration, I took 2 pictures for every QR code at a size of 20 by 20 centimeters. I started by entering the Python script. Then I went ahead and scanned the first QR code. In this case, the QR code I'm scanning contains the bin number 25,000. As you can see, the pictures get stored directly into the folder 25,000. Next, I follow by scanning the QR code belonging to bin number 100. And just as before, it stores the pictures into the folder that belongs to this bin number. Next, the third time I try to scan the QR code, it gives me an error, as it can be observed by the red lines in the code. This happened because the QR code that I've tried to scan is now valid, which means that the data stored does not contain a bin number, but something else. This prevents to store false data into the database. Then I scan QR code 17. This contains a valid number, and therefore the QR code gets decoded and the pictures get successfully stored into folder number 17. Finally, I go ahead and open one of the pictures in this folder, and as you can see, the pictures was successfully taken and stored, and the resolution is pretty good. At the end, I go ahead and open the CSV file that has the bin numbers and the path to the pictures scanned, which can be used as backup in case the SQL database fails or becomes corrupted. The second demonstration was recorded outside, and same as before, I go ahead and open the Python script. As it can be observed, the Raspberry Pi V2 camera decodes a QR code with bin number 17. It then stores the data and stores the pictures into folder number 17. And just for demonstration purposes, I decided to change the amount of pictures to 6 pictures.
So the admin creates users and also edits the bins that the root goes through. So these are where you can manage your bins and manage your users. So for, let's say you want to add a user, so you want to put let's say Richard Roger Rich 07 password, and then you make them an operator. And this could also remove that same, so you'll want to put the username, so we could do that, and then it removes it from the database. And then for bins, all we show on here is the bin code and address. We also have the file path and the pickup date, but we don't want to show be able to update those, because then those are created automatically when the root is done. So we don't want to edit those. And also the same for clock in, clock out. Those are non-editable.
Hello, this is a demonstration of the client-side PostgreSQL database system. We were tasked with making a system to allow clients, or trash bin owners in this case, to upload any complaints they had about how their trash was being collected. So we decided to settle for a website that can be accessed from anywhere, a website that could send data to a centralized server to store that data in a PostgreSQL database. Now, we decided to use the Heroku Cloud Platform to host the PostgreSQL server. So therefore, the URL the client would have to type in is lpkbpd.herokuapp.com. Once they type this, they would just simply go to the very bottom, and all they have to do is focus on filling out 3 forms. The first form is simply the bin number of their trash bin, so let's say it's 75432. 1. The 6-digit identification code for the trash bin owner. This is supposed to help database administrators determine if the actual request was made by the real trash bin owner, not some spammer. So I'll just type in a number for that here. And then, of course, they type in their complaint right here. Let's say the QR code ripped off. That could happen. So then they would click submit. And they would basically see this. This is actually just the JSON data form that the centralized server generated and sent back to the user. It helps the user determine if their data was actually received by the centralized server. Now, a database administrator that works at Lubbock Waste Management can simply view the contents of the database directly from their own Linux terminal as long as they have an internet connection and a computer. That's the benefit of using the Heroku Cloud Platform. They're going to need the command psql PostgreSQL version 12.2. And in order to log into the database, they will have to type in this long command here, but it's actually not that hard to understand. This simply represents the URL for the actual Amazon AWS server where the PostgreSQL database is served. This is the port number, so it's served on port 5432. This represents the username that needs to log in to view the correct database, and this represents the database name itself. Once they click this, they'll have to type in their password. And once that happens, they'll basically see a prompt that looks like this. Just like that. And the administrator can simply type in /DT to see all the tables made so far. And the one database table that's actually being used for this demonstration is the demo table. In order to see the contents of this table, they can simply type in select asterisk from demo, and that's it. We can see clearly that the information here matches the information that is directly on the website. This summarizes how the client can send information and how the Lubbock Waste Management can view that information directly from a standard Linux terminal. Thank you.